Hi everyone. I thought I'd just quickly introduce myself. Ko Sani Dama toko ingoa. I am from Waiuku College. I call Waiuku College my school now. I used to teach at Pakuranga College before I moved to Waiuku. I'm the head of maths and business at Waiuku College, and it gives me a strange new perspective on maths and business in New Zealand. And Waiuku is a small community. We've got 1,000 students, and there's a lot of our students wanting to go work in trades or the steel mill, and the recession's a bit not recession, the current job market is making it harder for students to leave. And so we have students at school who want to learn and maybe not the traditional types of students that I would have had in different parts of Auckland. And so it's been a real fun journey for me. I suppose many of you want to know why I'm here. And I'm here not as an expert. Because hey, we're all learning, and we've had this new curriculum document pushed through. We've got a draft for years 9 to 13 in the mix, and I'm not talking at it from a high school point of view. I'm really talking at it as a what can we do with this refreshed curriculum as a community of maths teachers, all the way from our primary colleagues all the way through high school. So I'm not going to look today to unpack every bit of the refreshed curriculum. I just want to show you what I've sort of got, a passion I've got, something that's really close to my heart, and I want to show how I want to use the refreshed curriculum to sort of be that vehicle. And so I'm about to say something kind of controversial, but I think we should be teaching mathematics more like an art and less like a science. I know that this is pretty novel. This is different. This is, you might say, oh, Sonny, it's you're getting rid of the rigor, you're getting rid of the structure, or even the curriculum. But that's not sort of my point. It's not about throwing out the structure or the rigor or the curriculum, but it's bringing the creativity, the joy, and the meaning that maths can hold back into maths learning. And the good news is the refreshed curriculum actually supports this kind of shift. Um, so feel free to put in the chat if this is something you're not happy with, but this is what I think is a shift that I've been making and my department has been trying to make, and it's something that I think we as a community should be looking at. Okay, why this conversation matters. A, maths anxiety is real. So there's a lot of anxiety around mathematics learning, and that's not just in our students, but it is in with our colleagues, it is with our administration. A lot of people go, "Oh, maths, ugh. Oh, I'm glad I don't have to teach that." Or a lot of people are in the mindset that, "Oh, maths is so black and white. You've either got it right or you've got it wrong." And that sort of mentality makes math seem quite fixed, cold, or something that's negative. Um, I want you to take a little minute and then put in the chat. Can you remember a time whether you either feel you loved maths or you feared maths? And type into the chat, what was it that made you feel so? A moment where you either loved maths or a moment where you feared math completely. Just type that through the chat. I know there's a lot of us in here, but I think it'd be really useful to just quickly l- see the lay of the room, see what other people think as well. And then I'll give you a couple of minutes to do that, and then I'll have a read of a couple of them.
Bearing in mind we're an unbiased, sorry, we're a biased sample of maths teachers.
Yes, that's right.
We've got
But
through to the end.
yeah. But in saying that, I've got teachers in my faculty who are really scared of some parts of mathematics, and that's okay too. You know, so give it a go. Okay. Thank you, team. And I'm hoping, yeah, there are more responses. I'm hoping often you see that the fear that does come into maths, and there's a comment in here. Our teacher focused on the top group, and I wasn't in the top group. Really interesting. Often the fear that comes into maths isn't the maths itself, but often how it was taught, or how you were grouped, or you know, how you are marked. Often sometimes you might, and I've had this when you're either right or wrong, and you feel pretty silly if you're wrong. And sometimes, maths was, hey, you need to know all of your times tables, and if you didn't, you felt dumb and you felt pretty left out. So, um, I want to sort of come back to this idea of science and art. And by no means am I bashing science in this pitch. But science, how I've sort of phrased it, is math being with precision, with rules, and focused on correctness. And art, I've been sort of pitching in the sense that it's about how you express what you're thinking, the patterns and the meaning behind what you do. And I want us to take another quick think. And I think I can be pretty honest. Um, Most of the time, I and most people lean towards a scientific approach to maths. Can you just quickly, just in the chat, type in the word science or art as to which you lean towards more often? And I know when I'm giving my notes and I'm going, hey, you've got to learn Pythagoras in this kind of way, I'm leaning quite towards science. So put in the chat and we'll have a look to see how many people are more sciencey than maths. Oh, cool. Okay, there's a few arts in here. Oh, yeah, I like the proportion. There we go. Oh, excellent.
As me being indecisive.
Thank you, Michael. Wow, there's actually a lot more people suggesting maths as an art than I had expected. For me, I think with the last curriculum and the way I was sort of leading it, I always wondered, how do we get enough across? How do we get appropriate teaching without it being, oh no, I've got to shift my students in year nine from curriculum level 3 or 2 all the way up to 5 or 6 by the time they're in year 11. That was a huge ask for me. And yes, teachers did have flexibility, but that uncertainty of how much of this content is enough sort of made made it really uncertain for some people. And with OTJs and things like that, I was feeling a lot of anxiety amongst teachers, especially in my primary and intermediate sectors, who are like, oh, we're teaching at level 5 for this topic, but we're also teaching at level 5 in high school, and our level 5 and your level 5 haven't sort of coincided. And this refresh curriculum, when I read through that the 5 phases, the rough bands of years 0 to 3, 4 to 6, 7 and 8, 9 and 10, and 11 to 13, um, had progress outcomes, not just achievement objectives, but the year-to-year expectations sort of gave me a sort of, okay, if I was a teacher, this is what I would be expected to cover. I know that, however, not all of my students are at that level in each year, and I know the government's got an interesting sort of take on where that is. But for me, as a math specialist, I'm really happy. But for my primary colleagues, I think it gives a lot more clear direction as to, hey, make sure these things are jotted down before you move on. And for students, they can also have this tick grid of, here's the things I need to learn. And I find that quite comforting. And I know a lot of math teachers that are finding it comforting. So I've got to make the most of what this refresh curriculum is. And I think coming back to why I like the refresh curriculum, I think this big idea of the understand, the know, and the do is what's sort of driving me to go, yeah, I'm gonna be comfortable with this curriculum. The understand is probably the biggest shift that we've had in being explicit because I don't know how explicit we've been in the past in the classroom about the fact that maths is about finding patterns and variation in the real world, about logic and reasoning or visualization and application. Would I be able to get my students or any students to quote that that's what maths is about? Because most of the time, whenever I ask students, hey, what are you learning in maths? It's more, I'm learning about algebra, I'm learning about measurement, I'm learning about statistics, or I don't know, whatever my teacher made me do. But I think the no is easy for us to sort of get across and explain what we're learning. But the understand is what I think this new curriculum has given teachers a lot of power to sort of spend a bit of time explicitly teaching, right? Um, it explicitly tells us, hey, give the students an opportunity to ask, why are we learning this? And what is our overarching goal? Okay. And the fact that if your overarching goal was to get to improve the fact that improve reasoning, we've got many aspects of mathematics that will get to reasoning. You can reason through statistics, you can reason through algebra, you can reason through geometry. And the reasoning is the skill the student's going to be taking away. And for me, I found that really, really, really encouraging. But we look at it. The first pages, when I gave my faculty, hey, here's the draft curriculum, we all went to the no. We all went to the tick grids of, hey, this is the expected coverage in year nine, this is the expected coverage in year eight. And when I met with our kahuiako, this is the expected coverage in seven and six. Um, and I challenged people and I said, hey, can we build our learning on getting students to understand these three big ideas of patterns and variation, logic and reasoning, and visualization and application outside of those no's? And often in a science classroom or a science sort of lens, you might go, oh, I've got to teach Pythagoras. I need to teach this formula. They need to be able to plug in numbers into this formula. They either need to be able to find the hypotenuse or find the shortest side. Um, and that's such a formulaic approach. And yes, it's really powerful. But I want to spend a bit more time going, hey, there was a whole bunch of mathematicians that spent a lot of time coming up with novel proofs for the Pythagorean theorem. And most of the time, it didn't need to sit with x squared plus y squared equals z squared or a squared plus b squared equals c squared. Those didn't matter so much. People made it with cubes, made it with squares, made it with triangles, made water little contraptions. And I know you know what those are. But how interesting is that? How helpful is that for a student to go, ooh, this is creative. This is so fun. How do we bring that back into the classroom? Okay, because honestly, how often do we spend teaching Pythagoras with a visualization as opposed to, hey, just do the formula, mate? I look through the nose. It's really interesting to see that geometry and space, they've gone back to geometry for many people's joy. And I like how they've explicitly come back to these do's. But I still think we need to be really explicit in our classroom that this is what mathematicians do. Mathematicians investigate those situations, represent situations, connect situations, generalize finding. But what does generalize mean to a student who doesn't see maths as something we can talk about? If a student only sees maths as a give me the answer, that's all I care about, then they're not going to see the value of discussing mathematics. Okay. And so I have a friend who's an arts teacher, and they don't mind that their students spend hours practicing strokes, practicing their pencil work, practicing, taking prints or practicing getting all of the blending of the colors right. They do a lot of that. And the finished product is better the more practice the student has. And mathematics is often the same. But how much emphasis do we give to the practice? And I now know that it's harder and harder as a classroom teacher to emphasize the practice as opposed to the test at the end. I'm finding it challenging. We at our school don't have workbooks, as in like, the ESA, here's the year nine workbook, go through. And students often are like, can I just write the answer, sir? And that shift of the answer being important to the process being the important is something I want to talk a lot more about with my students. And so with my students, I have explicitly said to them, hey, I want to stop teaching maths like a science, and I want to teach it more like an art. I want to be creative with maths. I want to challenge you to be creative with maths and not just get bogged down in the minutia of, oh, has your algebra been written clearly? Yes, your algebra needs to be written clearly. But when I teach algebra, I'm not using X for a little while. I'm using a box. I'm getting students to feel comfortable with moving boxes around, or I'm using bits of paper and moving them around because it's hard for a student to get to the abstract without some tangible connection. And I'm finding it a lot more instrumental if students are able to put their hands on something and move things around. I've brought Wang scales back into the classroom, and I'm like, if three of these weigh this and six of these weigh this, one of this is twice this. That's helpful in the algebra sense. And I don't know if students in upper primary or lower um, high school are getting a chance to make those connections. I had a student in my year 12 class, you know, not very confident in mathematics and really unsure as to what the definition of an odd number was. And that's really hard for me. I don't know what an odd number is. And I was like, okay, tell me what you think. It's either the numbers that end in 2, 4, 6, 8, or the numbers that end in 1, 3, 1, 3, 5, 7, 9, sir. So she knew that there was a distinction between the numbers that ended in 2, 4, 6, 8. And she knew that there was a distinction between the numbers that ended in 1, 3, 5, 5, 7, 9. But she didn't know what the word odd meant. And it wasn't a language barrier. But she'd never connected the fact that we use the word odd in the same kind of way that if there's an odd one out, something's left over. And that kind of mathematical understanding somewhere through her teaching to her learning has been missed. And I felt for her because she's trying really hard. We're trying to do networks at level two. It's a fun standard. And I looked back and I said, wow, she's probably not spent time drawing odd numbers as, you know, a whole bunch of circles with a circle left over, or a whole bunch of men with a single man left over, or a whole bunch of pairs of things with one left over. And I was like, man, we've done a disservice. This student has got to high school and either forgotten or not experienced enough of this. And so, to my primary colleagues, with this refreshed curriculum, the opportunity to represent, to connect, I push and I implore that we shift to this idea that we should experiment, we should play with this, and not so much just get stuck on, hey, I need to get this curriculum done so that they can move on to the next book, or I need to get this list of pages done so they can move on to the next. The learning is a lot more intense when the students understand how to make those patterns. I had students in my year 12 class, or year 11 class, sorry, who had never seen Pascal's triangle, ever. And to me, that was hard because I wanted to go, hey, let's break away from what we're doing. Let's go explore how we can highlight different things in Pascal's triangle. But I'm restricted by time. I want to do it. But in my junior school, that was probably more useful. If that student made connections with Pascal's triangle a little bit more, then they might have been able to find number patterns a little bit clearer. They might have been able to make connections with how numbers sit together, how multiples of five end in five and multiples of six are the same as multiples of two and the multiple of three. But the students are not seeing these patterns in these numbers because so far numbers are so, oh, you've done this question, you've done this thing, we need to move on. But you've not spent a bit of time to go, hey, how many different rectangles can you make with, an area that's 60? So far, I know in my year nine classes, if a student's got a rectangle that's 6 centimeters by 10 centimeters, 60 square centimeters is the answer. Or is it 60 centimeters squared? Students, the notion of what does it mean by Mr. Dama saying 60 square centimeters as opposed to 60 centimeters squared? The algebra element of squared and the square centimeters, the fact that we're actually counting squares, is a miss to some of these students. And so I get a student who is comfortable writing down 60, but is not comfortable connecting that to 60 squares. And so when I ask them, can you draw a rectangle with an area of 60 square centimeters? They don't they don't make the connection as quickly. They don't go, oh, actually, I can go a 1 by 60. I could go a 2 by 30. I can go a 3 by 20. That I want to explore more of. And in the curriculum document, what I saw, and I was very excited. And this is from the phase one curriculum document, but I think it's really cool. I think it's really nice that the structure of a lesson has been made very explicit, because structure is still important. I'm not saying we lose structure, but this idea that every lesson should introduce some new challenge, something to get students to engage, and something that students would always find different. I don't think we need to spend year ones, two, three talking about, hey, you know, here are equivalent fractions. I don't care about equivalent fractions. Great, do equivalent fractions when you want, but get students playing with, here's a pizza. Put the same amount of pepperoni on each slice. Hey, here's, here's a shopping bag. Make sure that every shopping bag has the same amount of food. That kind of division and that kind of practical skill will be a lot better for the student than spending it trying to rationalize, or sorry, simplify fractions. Because by the time they come into year nine, I want them to be able to equate equivalent fractions. But if they've not performed the skills for that, then they're not going to get that, right? So if I said to a student, there are 10 bags and each bag has 5 apples, how many apples are there? I want students to experience that with apples, with bags in the classroom. Can we get that happening? I've brought in, carrots into my year nine class last year. We did ratios with actual carrots. Students were so much better off. I put 3 carrots and 6 strawberries in a bag. Yes, I did. The strawberries got squished. It was a bit of a messy time. But then I said, what if I had 6 bags? And students actually went and got 6 bags and they counted this. This is when strawberries were cheap. I'm so sorry.
So how much do they pay you down in Waiuku, mate?
Mate, it was when strawberries were cheap. I had to do something because these kids were not getting ratios and I needed it to be more physical. Physical because the amount of times I wrote 2 to 6 on the whiteboard and getting kids to simplify that to 1 to 3 or make that more complicated to 200 to 600 wasn't happening. But the moment I made that physical, the students were like, yeah, okay, we got this. And I think our learning opportunities, and I might be preaching to the converted here, but I think we've got to be explicit with our students about the fact that maths isn't necessarily needing to be taught like a science. Get them to play with it. Um, the curriculum has given us lots of little bits of evidence. They've got, visualization is really important. Patterns and relationships are central. Students communicate through the learning process to share their thinking and reasoning. That's really important. If students are just focused on writing the answer down, they're not communicating. And if they're not communicating, they're not having this experience. Imagine going into an art class and just hearing about things and not making mistakes, not drawing terrible circles until you got really good at drawing circles. We need to do that in class. I've got some strategies, but I know you guys have some strategies, but there is there is four things that I think we really, really need to build into what we do. Those four things are we've got to spend more time asking about the why we're learning something or why something can happen. And I know it can be tedious, but we've got to embrace that. I know we teachers sometimes struggle with answering the why as opposed to the how we do something in maths. But ask students to show several different ways. And I know this is getting really scary, You might be like, Sonny, there's a really good algorithm for multiplying. Good. Don't mess with that. But I want students to show what an odd number is. Really get what an odd number is. I'm not sure if there's some stuff happening in the chat, but I think the other thing with maths is students needs to be praised for trying something curious. Often, if someone gives us a slightly not correct answer, we're like, oh, or asks a question that's a bit off. We go, oh, can we stick to what we're doing? No, I want to celebrate that. The whole Socratic method for how learning had happened prior to where we are now was that people ask silly questions, people ask questions, people ask questions that they were genuinely curious about. And I want that in the classroom, right? In an art class, what happens if I eat the paint, miss? Great question. You know, it happens. But in maths, where do we get that kind of flexibility to try something weird, right? Um, and allow multiple pathways to the solution. And this I I got because our school was just spending a bit of time talking about UDL, Universal Design for Learning. And people asked, hey, why is it that some kids can use, speech to text, or some people can get student teachers reading the question to them and others can't? And I was like, yeah, okay. Why can't we think of maths in the same kind of way? Why can't we have maths be represented in several different ways? Why can't we give students opportunities? I know the costing of buying carrots and strawberries might be expensive, but we can print out pictures of carrots and strawberries. What I am saying is, I think, especially by the time we get to high school, we assume that they know all the tangible, let's play around with physical things in maths so that we don't do it so much in high school. But I think that kind of learning is super critical all the way through, even to year 13. And so let's not shift away from actual using physical things or playing with things or ripping up paper in weird ways to show that you can make 360 degrees. If you get a rectangle, cut off all the corners, 360. Any quadrilateral, if you cut off all the corners, put it together, it's a really fun experience for students. When I did tessellations, as opposed to giving a kid a picture and go, tessellate this, get a square, tessellate it. I think there's some questions in the chat, Michael. Um, should we pause to have a quick look?
Yeah, just a couple of people were reflecting on kind of, including myself, about your comments. No questions as such, but
Okay. All
um,
right. Sorry. I don't see them straight away, and so that's why I'm just asking. Um, but for me, I did this and I gathered some student voice, a little bit of student voice from my class. Okay. And the student voice I got I asked them some questions, and and these are the three that I sort of want to sort of think about. I thought I was dumb because I didn't get it. You know, I liked when we chalked shapes outside, right? This is year 9 and 10 students, right? I did these things outside with them, right? The joy of learning happens if we do a bit more of this stuff. Maths was fun when we got to make stuff. And this is in reference to when I taught transformational geometry by cutting things out, as opposed to getting them to try and draw. Because some of these kids can't write three the same way 3 times. And that's not their fault. And so how are they going to understand symmetry unless they actually have something symmetrical? Their threes are not symmetrical across the middle, like our computer threes are. And so how are they seeing symmetry? Or I asked, and I did this. I got them to write out the alphabet and asked them to tell me which letters were symmetrical. Some of their handwriting made it really hard for us to find anything symmetrical. O's weren't symmetrical. B's weren't symmetrical. M wasn't symmetrical. So how the student that said, I thought I was dumb when I didn't get it, was talking about when I was doing that symmetry lesson, and I'd written the letters beautifully on the board, and they'd written in their book, and they're like, "Sir, X has no symmetry." And I was like, "What are you talking about? Look at the X on my board. It's got beautiful symmetry." But the X in their book didn't. And I felt so bad. Because what's happening is we're holding students to the same standard of writing, same standard of learning that we would have gone through. And maybe they haven't had that experience. And that's why I'm curious to try and do this in a different way. So I took 5 small steps. And then I've got AI to help me with a little bit more. But my 5 small steps in my classroom, and I get my students to do this too. Um, I ask more open-ended questions, sure, but I get my students to ask each other more open-ended questions, you know, instead of saying, you know, how many solutions are there? That's really cool. I asked, how did you know you've got all of the solutions? Right? I don't, that kind of shift was them getting to, I know how to get to the exhaustive end. They were able to explain that a lot better, right? I went away from, back to that alphabet lesson where I then printed out the alphabet and then got them to go, how many of these letters are symmetrical with mirror lines? I was gonna ask, how many letters have mirror symmetry? But then I changed that question to, how do you know you have found every line of symmetry in this alphabet? And for me, that one shift of question, students were able to go, oh, I've not only just looked for the ones I think there are symmetry, but I've looked at every letter and I've determined that there's not symmetry. Because that kind of process of cancellation is also just very important. Students really enjoyed that. I like telling stories, using visuals, get students to draw their thinking. If we're going to talk about strawberries, I got them to draw strawberries. And this is year 9 and 10, I'm doing a lot of. I got students to celebrate their process. The clearer that they can show me their thinking, I got them to write the answer in the bottom right-hand corner. I didn't look at that. I put my hand over it and I looked at the process. And I was celebrating that process. And if the answer was right, great. If the answer was wrong, the student was able to find the process. And I did some algebra with students. And I said to them, the answer doesn't matter. I'm going to cover it up. I'm going to come and look at the process. Can I see that you've done the same on both sides? Can I see that you have, written X's neatly? Can I see that you have moved things around? And then I want to talk to students about maths as creative and evolving. And this is something that is in the curriculum, you know. I Maybe it was a bad idea, but I talked to my year nines about graph theory and how, you know, recently we've had such an explosion with AI and stuff, and it all comes back to, some guy walking across bridges. And if that guy didn't have that issue with, can I walk across each of these bridges exactly once? We might not have the neural networks that we have now, right? That whole branch of mathematics happened because someone was curious about something mundane in their real life. Um, and I know I'm running out of time, but I'm sort of just gonna finish with a couple of, I don't know, points of why we need to sort of move in this kind of direction. The risk of doing nothing at this point, and I know with the amount of students that are having learning difficulties, is we're going to get more and more learners disengaging, right? We have this opportunity with this refreshed curriculum where we've got explicit understands, explicit do's, explicit instructions to teachers as to what to cover in each year. And I know students are going to be at different levels, but that is what we're going to see in the test, the result. But the learning, a student can have a much richer experience. That all learners can have rich learning experiences with rich tasks and with open-ended tasks where some students might, you know, stop here. Sorry, you can't see my hand. Some students might stop here, but some students might stop all the way up here, or some students might keep going, right? I don't want maths to be a gatekeeper to success. Okay. Um, with the numeracy co-requisite and the challenges there, people are throwing it to maths, saying, Maths, you're not doing a great job. But it's not the maths. It's the fact that students are not able to apply the learning they've done in class to real world contexts. And so I really hope that by visualizing, by talking about practical things, and by the artifying of maths, where we celebrate, drawing solutions, celebrate, being creative with our answers, the students will continue getting not having their confidence and joy shattered in the maths classroom. Um, the opportunity is we're going to build curiosity. Curiosity is a very mathematical thing. And I don't know if maths and curious are linked. And I know I might be preaching to the converted here, but this is a message we need to send not only to our maths teachers, but to our teachers in other faculties, in our SLT, and our primary and intermediate colleagues. Hey, let's celebrate maths. Let's not treat maths like a right or wrong situation. Let's not play to this negative connotation. Art, no one has any issue saying, hey, you've got to practice your art until you get better. You might need to draw 100 portraits before you draw a really, really good one. And no one bats an eye. Or if it's music, unless you practice, that riff on a guitar, you're not going to get better. And if I can get more people to have this kind of conversation about maths, not just the maths teachers, but the whole community, the parents, everyone, we're going to have a better time. And this is why I say it's really important to build this into the vocabulary of the students. Because the students' mindset needs to change from maths being such a fixed idea to maths being something they can play with, something they can be curious with. Um, and then maths becomes a subject once again of joy and meaning. And in our level 3 classes, we might not have this issue. But I know in our year 9 and 10, the more we do of making maths curious, insightful, we're going to have a better time. Okay. And one thing I say to my students all the time is maths is not just about finding the answer. It's about finding a way and seeing what else is possible. Okay. It's not about just finding the answer. It's about finding a way, you know. And I really, really enjoyed talking about the Königsberg Bridge problem with my year nines because they were like, there is no way some guy walked these bridges this many times to figure out that there was no way. And I said, well, you've got to find another way to do it. And I was able to get students drawing on bridges several times until one kid was like, Sir, there's got to be a smaller picture we can draw and we can just trace around that all the time. I was like, cool. What's that going to look like? He drew little boxes for bridges and stuff, but soon it moved away from the bridges that I'd given him to something quite abstract. And that was finding a way to create maths. And maths is so powerful when it's done like that. And no, I'm not saying we should all do graph theory with all of our year nine classes, but we can do this in everything we do. Um, the next 30 of my slides are not going through, but I've got little tips and tools that I sort of have as an approach. So when I share my slides, so you can have a look through, um, you can see what you like and use what you like. Um, because sometimes we just need a bit of an idea before we can do something. And so I've got 30 ideas here. One of my favorite is maths is like an art, right? I got students to create number patterns using threes and sevens. And then they were like, oh, and they were drawing pictures, they were drawing number patterns that weren't about numbers themselves. And we went and had a whole symmetry lesson on this, because threes are symmetrical, sevens are not symmetrical. They were typing it on their computers and making little fractals of threes and sevens. It was so fun. It didn't have anything to do with the numerical properties of three and seven, and only with the geometric properties or of three and seven. And I really enjoyed that. We changed the fonts, and I think students learned so much better there than three is this and seven is this. And I really enjoyed that. So have a go. These will be in my slides.
We'll share these slides next week. Yep.
Okay, perfect. Um, so for me, um, I know I've done a lot of talking, so I'm going to stop now. But in the chat, I really hope that you're able to go, yep, we agree, Sonny, maths should be an art, or should be taught more like an art. I'm not saying we lose all sense of structure, but can you go out there and have this kind of conversation with your colleagues in other subject areas, with your colleagues in SLT, and with your communities and go, hey, we need to shift this negativity towards maths because otherwise we're not going to move. And this refreshed curriculum gives us that because it specifically says those understands are really important. And we can only do those understandings if we focus on being explicit there. And the do's, they're not going to generalize or find patterns if we don't give them opportunities to do that. So that's all I've got. And I know that's big
Brilliant
numbers.
timing, Sonny.
Thank you
Perfect.
so
It's
much.
like almost like you prepared. Um, like on behalf of the Auckland Maths Association, of which you used to be a part of, like I really appreciate your giving up your time on a Saturday to share such positive, inspirational comments. Look, I really liked how you highlighted the positives in the new curriculum. Yes, you said that it's explicitly said what the non-negotiables were, but the focus on enjoyment, creativity, and reducing maths anxiety as a result is definitely the highlight there. Like I just think yesterday in my calculus class, um, what I had to get through was to teach them the equation of a circle. Like if you know the center and the radius, boom, that's the equation. And that took 2 minutes, and the rest of the lesson was spent on exploring how you find equations of circles using points that aren't the center and the radius.
Yeah,
Uh, and we ended up doing all sorts of stuff about geometrical construction, and we went off on massive tangents. But the students there, I think, got more out of that lesson than they would have got out of doing the stuff that I had to teach. And we, for so many years, have focused as maths teachers on like content driven kind of approaches. And when you ask the students, as you said, what did you learn in the lesson or what's maths all about, they focus on the content as opposed to the process. I think students learn a lot more from investigating questions that are um, that maybe that break that aren't like typical problems, and technology allows us to do that as well. So like really cool, Sunny. Thank you for putting your twist on that. And I know based on the comments that are coming through in the chat for you that people found your words inspirational. So really
awesome.
appreciate it. Cheers, mate.
Thank you.